All right, thank you, everyone. Hey, to kick off this month's session, I wanted to share something that our customers have told us about. And what our customers have told us is that whenever they question something going on in their environment, they say, "Did you chroma check it?" And I'm like, wow, that is so brilliant because everyone always has questions about is the printer right? Is that color on the printer right? Or is the light booth right? Or is your measurement instrument right? Well, did you chroma check it? If you've chroma checked it, ChromaChecker will tell you if it's right, meaning if it's accurate to the level of expectations based on your E factor of how close you need it to be per your customer's requirements. So I hope that everybody starts asking anytime there's a color issue, did you chroma check it? It can even be your lighting environment for how you're looking at prints. So did you chroma check it? Now, this month's session is on digital press accuracy, precision, and gamut. It's all about continuing our session from last month, which is the benchmarking of printing devices, and ideally benchmarking these printing devices before you bring them in-house. Because ideally, you want to make sure that any new digital press you're bringing into your shop aligns per your expectations of a color match using E-factor with your other printing devices. Because the reason you're bringing on another printer is to share work between your printers. And if you can't share work between your printers, that printer becomes effectively a boat anchor, which we've all seen happen with print shops is you buy a printer and it doesn't really do what you're hoping it to do. So if you chroma check that printer first, you'll know that it will align with your other printers and match color. Now, we're going to talk about our upcoming ChromaChecker activities. We've got an Engage 360 event coming up the day before the print show in Orlando. I'm doing a presentation on the 6 key trends of the print industry and how color conformance makes all those trends possible. If you want to come to this, it's a free event. It's invite only. Let me know. I can get you an invite. Of course, we'll be at the Printing United show, booth 4268. If you want a meeting with us, please set up a time with Beth, and we'll be sure to take as much time as we need to go through your color issues. And then, of course, we've got our color conference coming up February 3rd through the 5th in Newport Richey, Florida, which is about 6 months away. And we've got some new sponsors this year. We're hoping for an even better turnout with a great content aligned for you guys. So now, some recent improvements. I want to focus with you guys and help you. Please go under if you're a ChromaChecker user and you want your business to have more sales, go under the sales registry icon. It's underneath the human head icon on the main window, and there's a printer sales registry. Register here, and any of our print buyers and brand companies that are using ChromaChecker will be able to find you through this printer sales registry so that they can publish projects to you and they can send work your way based on the type of work they need. We've also had ChromaChecker customers asking, hey, who else has an HP Indigo? Because I don't want to buy another Indigo yet, but I have too much capacity for my current Indigo. I want to share work with somebody else, and I want to make sure they're using ChromaChecker because I want to make sure they chroma check it so that we can share work and we know it's going to align. So please go ahead and register under the printer sales registry. Other improvements that we've made to ChromaChecker within the last 30 days is we've added the new SDK, which has greatly improved the performance capabilities of the Exact 2 instrument. We've also added the ability to add up to 2 data loggers per printing device because we have situations where you want to keep track of the temperature and humidity outside the printer, but also inside the printer. We're working with a company called Vioria, which you can look on our website and learn more about their inline measurement device. Their measurement device actually feeds us the internal temperature that we record in the ChromaChecker dashboard. So if it exceeds a certain level, it'll warn the user, it'll warn the person in charge of that they need to make a change to ensure that the color is correct. For one of our customers, we've also customized I'm not sure I'm going to say this right, but Arduino data logger stations. These are fairly inexpensive data logger stations, which have 4 temperature channels and an airflow channel. So now you can compare temperatures with airflow, which requires a little bit of development on the customer side because the Arduino is not a plug and play solution, but it's not difficult. And if this type of thing is important to you, we can now support it. And that's a graph down below of the airflow versus temperatures and how you can see the cause and effect relationship between them. And over on the right, you can see the screenshot of the T1 through T4 on the right-hand side that's showing you the readings from the different temperature gauges. We also have added a new PDF label size for those of you that have asked. It's 4 by 6 inches. I also have to tell you again about our artificial intelligence module that's built into ChromaChecker. It works in 20 different languages. It's on the cloud. It learns as you go. And we've gotten great feedback from our users in terms of how it's helping them figure out how to do things in ChromaChecker, which they were struggling a little bit with. And one of the things we did just recently was when we first implemented it, it would tell you what to do, but when you clicked on the window in ChromaChecker to do it, the AI assistant would go away. Now we've kept it live on the screen. So when you can go and do what it's telling you to do and you don't have to take a screenshot of it or anything else, it stays live, which is great. And of course, we'll have artificial intelligence modules in the future to not only help you troubleshoot and solve print problems, but also build reports. We find that so many people love ChromaChecker reporting, but it takes a certain level of expertise to configure the reports, which we've done these sessions on to help you understand how to make the reports. Well, now with our artificial intelligence module, very shortly, you'll be able to say, hey, I want to know how my Epson 1 manufactured color over the last 2 months compared to my Indigo 2. And it can grab all that data, make a side-by-side comparison report for you so that ChromaChecker has the data. Now we're using intelligence to give you the data in an easy to use way. So very exciting changes and improvements with our ChromaChecker platform. Today, as I mentioned, we're going to continue our ChromaCheck benchmarking printers before you purchase it, focusing on digital presses. And we're also going to talk about how you can improve the printer accuracy based on the results, because oftentimes if you give a file, like we're going to recommend that you give a PDF to the company that you're looking at buying a printer from, give them this PDF, they print it, and if you can say, hey, I want to aim for Grackle, but depending upon the expertise of their personnel, you might get something straight out of the printer, or you might get something that's super accurate to the printer. Well, now with ChromaCheck, by ChromaChecking it, you'll measure this control strip, and then you'll be able to quantify how accurate in E factor it is to Grackle. And if it's not very accurate, then you can do things like maybe, well, from this data, you can create a G7 curve. So you don't need a P2P target. You can use this target to generate a G7 curve. And if they're using, let's say, a fiery rip, you can send this this curve in a VCC format that they can apply to their process, reprint, and give you a more accurate print of what you just got from them. And if you want to take it another step, you could build an ICC profile, which gives you a huge level of improvement in terms of the accuracy. So you can learn, even if the vendor who's trying to sell you the printer is not very technically capable, using your ChromaChecker system, you can figure out how good that printer can be before you buy it. Okay, very, very powerful. And I'm going to show you how to do a lot of this today. So please share this session with decision makers, because everyone's bought printers that they wish they hadn't after it's been installed. But if you ChromaCheck it first, you won't have this issue. Now, we're introducing, and Beth, please put that link up that I provided you earlier. We have done quite a bit of work with our project inspector tool in ChromaChecker. And the project inspector is designed to set all the parameters up for our users so that you don't have to configure everything from scratch, that the project is a pre-canned set of configurations that all you should have to do is take the page, print it, measure it, and ChromaChecker will tell you how your printer did. And the first project we're going to focus on is the accuracy to grackle project. And this project comes in both a tabloid size page and a letter size page. And it allows you to have your vendor print this target out of the printer they're trying to sell you. You get it back. You measure the CC112 target on here. And the reason you could also use the CC84, which is a 3-row target, but we've moved to CC112 because it has all the out of gamut patches in the proofing color bar. So this color bar here, this 4-row color bar for an I1, does effectively the same thing as a P2P and a 12647-7 proofing bar, all in one bar, all the same size as the proofing bar. So it's very easy to measure, very easy to get great data from this. Now, once you've measured it, ChromaChecker will tell you what the E factor is of this printer to grackle. And then you'll know, okay, how accurate is that printer, or how inaccurate is that printer? In addition, it'll tell you how accurate that printer is to other printers that you have in your shop. So ideally, you should have already printed something like this on your other printers in your office. And then this would give you the ability, ChromaChecker gives you the ability to see what the difference is between, let's say, this new Epson you're looking at purchasing and this existing Ricoh you already have in your shop. ChromaChecker will tell you what the E factor is of each printer to grackle. So like this printer, the E factor is 4.7 to grackle. This printer is 9.5. And using ChromaChecker, when I say, hey, what's the difference between them? It's about a 8.6. So it's a very large difference between this. But if I pull out the master grackle print, which is this print, which is part of our color tolerance exercise, it says master on it, which you guys can purchase for $99 or $79 if you use the special code for watching this seminar, which is Second Tuesday code. You can see that the print on the right is visually a lot different than the print on the left. The print on the left is a lot closer to the master than the print on the right. And it's a 4.7 E factor, and you can see that's actually a pretty decent match. Now, based on our research with print buyers, over 55% of print buyers would accept that match, where essentially 0% of print buyers would buy that match. So this allows us to really define whether or not the print is sellable. Is it sellable? If it's not, like in this case, we got a 9.5, I went ahead and using the data from measuring this target, built a new G7 curve, and reprinted the print, and I got a 6.9 E factor. So 6.9 is better than a 9.5, but it's still a ways off, although it is better. And then just to skip ahead, I used the CMYK ICC profile project, which we'll talk more in a second, which is essentially measuring our CC 400 target. And I built an ICC profile using ChromaChecker, using the measurement data. And I got this same printer that was a 9.5. I got it down to a 6.9 using curves, and I got it down to a 4.5 using an ICC profile. And I'm not expecting you to see this real well, but now when you compare the printer at a 4.5 to the master at my other printer, which is a 4.7, now we're talking color alignment. We are talking color alignment. Color alignment that you're not going to get using just G7 curves. This is the next step. This is all about aligning your printers, and ideally aligning printers before you buy them to get them where you need them to be. The third benchmark project that we have is a basic variation project, which allows you to check the variation within the page, within the job, and between the jobs. So you start learning what is the variation of this printer over time to help you understand how often you need to recalibrate it, how often you need to maybe redo a G7 curve, and how often you might need to do an ICC profile. But for this session, we're kind of focused on the accuracy project, because to me, that's everything. How accurate can you get all your printers aligned to your Grackle condition? And for your European users here, you can either change our Grackle project to an ISO coded project, or you can configure it to whatever standard reference you want. And then all the other parameters fall into place. So it's very little effort to do that. So here's what the project PDF looks like for the color accuracy to Grackle. One is a tabloid size, one is a letter size page. And so depending upon the format that your printer is capable of, you use one of these two PDFs and you print it on all your printers. And then you measure the CC84, and you'll see we've got this target so it can be measured with virtually any measurement device, whether it's an ISIS, an IO, FD, Miro 9, a Miro 1, a variable Spectre 1, a NIX, Spectro 2. All of these devices can be used to build the curves and the profiles for these targets. Now, getting back to my point of assessing the accuracy on all your printing devices. So you print it out, and you'll see here, I did pictures of these three prints, and you can see they are all different. But then what we do is we measure them and we enter the E factor numbers. And these are the exact same ones that I have here. So these numbers are relevant and real. 9.5, 6.9, 4.5. And then down below, you'll see down below, there's a place to click whether it was calibrated only, whether it was a G7 curve only, or if it was color managed with an ICC profile. So that, and you can of course put the date on here. So you have a history of how this printer was printing on this date. And it's very educational for people who really don't understand color, that, hey, here's what I get with a curve. Here's the improvement I can get with an ICC profile. Yeah, it took me a little longer to measure 13 rows versus 4 rows, right? That's about 3 times longer. So it takes me 4 rows to measure to build a G7 curve. It takes me 13 rows to build an ICC profile target. But I get about a 35% improvement in accuracy going from a 9.5 to a 4.5. That's actually more like a 60% improvement versus a 28%. I get double the improvement. You know, as I'm doing the math in my head, I'm getting double the improvement by using an ICC profile over just a G7 curve to match my original or to improve upon my original print. And for measuring what, 9 more rows, which on an I1 takes me about 3, 4 minutes, that's worth it. So hopefully you can see the benefits of ChromaChecking a new printer before you buy it, because you understand the level of color match to not only Grackle, but as I'm comparing these to one another, I can also compare them to my other printers. So when my printer's at a 4.5 to Grackle, what is the E factor to my Indigo? Is it 4? Is it 8? Because remember, and I'll show this in a graphic coming up, Grackle's a bullseye. If one's 4 E factor this way and one's 4 E factor this way, if it could be 8 E factor from one another, which again, no print buyers, if they're looking at the color, would accept that. They would reject that. That becomes waste. It becomes something you have to write off, which costs you a lot of money, $100 write off at a 2% margin on sales, which most printers make. That requires $5,000 of additional sales just to overcome that one $100 loss. So you cannot afford to not match color and have customers reject color. So the benefits of doing this ahead of time ensures that this printer can align with your existing printers and you can sell color between all of them. Now, the other capability of building an ICC profile is you can bring this ICC profile into ChromaChecker. Well, it's in ChromaChecker because ChromaChecker built it, but you can export it so it goes into your RIP, which I did for this workflow. But with this ICC profile, I can calculate the range of colors that this printer on this substrate can hit. So I can actually tell you what percentage of Pantone colors and which Pantone colors can be reproduced accurately within 1 or 2 delta E. And this could be very useful if you have a Verizon as a customer and you need to produce Verizon Red. You want to make sure that this printer you're buying to print Verizon Red can print Verizon Red. Because again, too many times people have bought a printer, it couldn't print that brand color, and it was a problem. You can also use these metrics that ChromaChecker projects give you for accuracy, gamut size, and variation to hold installers accountable as part of the PO. So when you write the PO, you make it conditioned on these metrics that when your printer is installed, it will meet these criteria that were demonstrated to you. So that, again, I think every printer's had a situation where there was an argument over when the printer install was done. Because the installer's like, oh no, I'm done. And it's like, no, the color coming out of here is horrible. It can't be done. And if you make it part of the PO, now you have a legal stamp you can stand on saying, no, this isn't done. You have to hit this gamut size, this accuracy, or you have to give them a little leeway, but it should be within 5–10% of what they've demonstrated to you, or they did a bait and switch, which I have seen. I don't want manufacturers mad at me, but I have seen manufacturers demonstrate the capabilities of one machine and sell another machine. And if you're not doing this, you'll never know. So key things. Now, E-factor numbers. If you're new to ChromaChecker, you might be like, oh, what do they really mean? And what it really means is it gives you a sellable metric of how close is visually close enough for your customers. And every printer is different. We've got printers who are running ChromaChecker to an 8 E factor. We've got printers that are running all day to a 3 E factor and everything in between. So the beauty of E factor is it scales based on the type of work and the type of printer and the type of customer you have. The pickier the customer, the lower the E factor. The pickier the customer, the more expensive the equipment has to be and the more trained the operators have to be to provide a lower E factor number. There's no free lunch here, right? You can't be asking for a 3 E factor at a budget low price. It doesn't work that way. Unfortunately, printers haven't really sold the value of what they can do. So it's a commodity and everyone's like, oh, I want the lowest price. I don't care what the color is. And for those customers, go ahead and give them an 8 all day long. But If the customer is going to start being picky in terms of the color, that's where you can start adding margin in terms of saying, hey, I've got these printers that can do an 8. I've got these printers that can do a 3. They cost more. What do you need? So it provides you a selling opportunity to differentiate your company compared to the competition. Because remember, most printers can't speak this language right now in color. They don't ChromaCheck their printers. So they just print anyway, any day. And so not only does getting this data help you align to your standards, but also align your printers to one another. And here's my dart target. So think of Grackle. Grackle is a color space representative of printing on a coated paper with ISO standard inks on an offset press. And then ideally, I want my Epson proofer to match Grackle as close as possible. So if I show them an Epson proof, it should be representative of how the press prints. But how many of you who have offset presses and have a Epson proofer can tell me what the E factor difference is between your Epson proofer and a normal press run? I know many of almost all of our ChromaChecker users can tell me that, but other people, even G7 experts, will look at me like a deer in a headlight going, what do you mean? How close is my Epson is G7 color space compliant? My press is G7 color space compliant as well. Could be. And yet when you put the two side by side, they could be dramatically different because again, one could be in the 3 o'clock position, one could be in the 9 o'clock position. They're both G7 color space compliant, but theoretically, they could be 8 E factor different from one another, which again, no buyer would accept. So quantifying how close each of your printers is in E factor to Grackle is incredibly useful. I can't even imagine how people run a shop without knowing this information, because now you know which printers are most out of alignment and need the attention to build curves or profiles to get them into alignment. So this is where you set what your E factor tolerance is after you have an idea of how your printers are printing. And trust me, nobody starts with an E factor tolerance of 3.5. You'll be lucky to start at a 6 to start because most people don't know how bad their printers are, frankly. And that's why there's so much waste going on and so much rejection. And how come salespeople always cross their fingers that when you give the print to the customer, they're going to say, yeah, this looks good. So being able to set a tolerance, it's a sellability tolerance. And it's easily communicated to everybody in the shop so that the salespeople know what your tolerance is for the printing device. Your operators know what the tolerance is for the printing device. So if you're running an Indigo and the print comes out and it's an 8 E factor, stop. Don't print anymore. That's all going in the trash can if it's an important customer because it's going to look like crap. And we know 8 is not acceptable by anyone. So fix the printer, update the curve with ChromaChecker G7 curve, or update the ICC profile with the ChromaChecker ICC profile and get going again. And then, as I've talked about, you can compare what the difference is between printers, which taking my G7 badge off here, this is more important than anything, is how close do your printers align to one another? And in this scenario, I have 2.5 in one direction, 2.5 in the other, and yet they're 5 E factor from one another, which means about 50% of the print buyers would reject this if you were doing a job that was partially on an Epson and partially on an Indigo. So that's an issue. Now, getting back to my example that I shared with you here, the printer out of the box was a 9.5. And then I applied G7 curves to it. I got it to a 6.9. And then I did an ICC profile and I got it to a 4.5. And my tolerance is a 5, and I've got it in line. So great example of where's your printer? What do I need to do to fix it? Now let's put this in perspective. If you guys are still using a P2P target to build G7 curves, oh my goodness, please think again. Either our 3-row or 4-row target can build G7 curves virtually identical to what the P2P can do. All right. And now, well, if you're going to measure 12 rows of a P2P anyway, why not measure 13 rows of our ICC profile target with an I1? And now you improve the accuracy over just G7 curves by 35%, and you increase the accuracy over doing nothing by over 65%. And then to put in perspective, if you kept this print that was G7 curved at 6.9, 30% of print buyers would accept a 6.9, whereas 55% of print buyers will accept a 4.5. So again, doing one extra row improves your level of acceptance by a general customer by 25%. Why wouldn't you do this? This is the way to manage your printers. ICC profiles. And you know what, guys? Frankly, I'll be clear here. Our ICC profiles aren't the best in the market. There's other programs out there that make even better ICC profiling tools than we do. We're a color conformance platform. We give you this tool to make things easy and try to help fix things, and our customers have asked us to do this. But if you have, let's say, X-Rite I1 Profiler, this 4.5, in fact, I should probably do this. I should rebuild this profile for my printer using X-Rite I1 Profiler, which I can't do it with necessarily 400 patches. I'd have to have more patches, but chances are I'll get that 4.5 down to maybe a 3.9. So there is the ability to quantify how good profiling software is, just like how good is my light booth, or how good is my instrument, or how good is my printer. Did you ChromaCheck it? With ChromaChecker, you can assess how accurate X-Rite profiling software is versus ChromaChecker profiling software versus ColorLogic versus EFI. Doesn't matter. But the beauty is you can know how to get the most out of your environment to give you the most accurate color. Think of ChromaChecker as kind of a referee. We just tell you where they're at. And here's how the 3 prints look in my actual ChromaChecker track. So the first print on the far left is showing a 9.3 E factor. Then in the middle was my 6.9 E factor. And then on the right was my 4.5 E factor. And the 4.5 E factor is green because my E factor expectations for the tracks were set at 5. The other ones were failing. And if you look at the, what else do I want to look at? Oh, you see the blue line down below? That blue line, the magenta line is the accuracy line of how accurate it is to grackle. That blue line is the variation line. So the first print was a little more than a 1 E factor. So the amount of variation within the area that the target was printed was about a 1 E factor. And you can see that in the graph down below, it says 1.1. And then the last measurement was a 0.9 variation. So at the same time we're checking accuracy, we automatically check variation, which is something nobody else does. And variation is really critical to understand how much a device moves within the sheet and between sheets. ChromaChecker does this for you. So this is why you need to ChromaCheck. So in perspective, talking about printing, benchmarking and ChromaChecking printing devices, last month we covered large format inkjet printers, and we provided a PDF target to use in large format printing and one that you can edit. This month, we're getting into the projects, and we're showing the accuracy to grackle PDF and the ICC profile PDF and the variation basic PDF. And so in this way, we have instructions on how to do a complete benchmark on your digital presses to see how they're printing color. Next month, we're going to do offset sheet fed printing. We have specific files built for plating that you can plate on your printing devices and measure the color strips off of these devices and benchmark what the variation is within your offset press between units, between pages, and what the accuracies are. So if you're interested in offset printing, come to next month's session and learn more about how to do that. Now, when all's done, and by the way, we're not the only ones doing this. Our users are doing this and submitting data to our ChromaChecker platform. And we have the ability to share the data between users. So if our users are okay with it, they can share how they benchmark, let's say, a Fuji XYZ press. And then someone else doesn't have to benchmark that Fuji XYZ press. This data will go on our master server that allows you to go in and see what printing devices or our customers have benchmarked. So you don't have to go through the steps of benchmarking the printers. You can see how these were benchmarked in the past or recently and compare how this Fuji XYZ printer prints with your existing Indigo. This can be used for research to understand which printers you should be looking at to bring these printers into a line to your printer. And we could do the same with an offset press or a flexo press. It's press technology agnostic. It can work across any print platform, which is, again, very unique. So this accuracy server, which is essentially a ChromaChecker account that we're allowing our customers to access, allows us to see if the printer prints any way, any day, or that's the left target, or the middle left is it's very precise but not very accurate. And that could be just due to customer or the representative selling the printer doesn't know how to make it accurate or might not have the tools to make it accurate. The middle right is it's accurate but not very precise. And the right is ideally what you want from any printer if you care about quality is accurate and precise, accuracy and precision. So when we're benchmarking our presses, we're looking at how accurate it can be, how precise it can be, what the gamut size is to know that we can create the colors and represent grackle and hit the given Pantone colors or spot colors that I need. And then there's a fourth page called the contrast resolution, which helps you understand really the resolution or adjustability of that print. Because I've seen printers advertise themselves at 600 DPI, and when you print our contrast resolution target off on these printers, one looks noticeably better than the other, even though they're both in spec sheet at 600 DPI. And this is part of a ISO committee that I'm in that is helping to quantify this contrast resolution so we can have a number that can actually go on a spec sheet versus us having to test it ahead of time. Now, here's a look at our master digital print server. And I've got a Domino press on here, and I've got a Fuji J press on here. And you can see we have the within page uniformity numbers. The Domino was a 1. The Fuji was a 1.2. The within sheet repeatability or within job repeatability through 1,000 sheet job was 2.3 on the Domino. And it was 1.1 on the Fuji. Actually, on the Domino, it was a 1.0 on the Domino, and on the Fuji, it was a 1.1. And then the accuracy, one was a 2.8, one was a 2.4. And then I could click on the test 3 and test 3 for Fuji and test 3 for the Domino and compare what the E-factor difference is between these two presses to one another. And it shows me here, I'm doing a Canon to a Fuji, but it's 4.7. E factors. So this helps us understand, okay, it's essentially the difference between this 4.5 and this 0. It's about that level of color difference. And that helps you understand, is that close enough for what you want to do? No other product on the market can do this. No other product on the market is even thinking about doing this. If you want to do this, benchmark your devices using our ChromaChecker tools. And we've tried to make it as easy as possible, works with virtually all measurement devices. And if you have a barcode reader, if you've bought a starter kit from ChromaChecker, you can just hit the barcode in the upper right-hand corner here with your barcode reader, and ChromaChecker will automatically bring you to the measurement screen to measure this control strip. That's how easy it is. If you don't have ChromaChecker yet, when you click on that link that's in the chat of this file, it'll bring you to this page. I'm going to quit out of the presentation and go to the page. This is what the page looks like. And your data, real results right now. So you can do it two ways. You can test ChromaChecker Fast Track, which we have some technical requirements and supported instruments here. So here's a whole list of instruments and what you can do with these instruments. And the concept is that when you go through this fast track, get back to where that was. When you get to that fast track here, you can just download Capture, which is the client software that connects to the ChromaChecker cloud that drives all the instruments that we talk about here, and just print and measure the color bar and get going. If you want more of a overall analysis, go to the right here and say try sample projects. You'll enter your email and you'll give it like an organizational name. So use something like your company name here. So something like ABC Litho. And then as you say start trial, it's going to set up your own color cloud and your own trial with projects that you can go through and assess the gamut and assess the variation and assess the accuracy to grackle and compare your presses to one another. So you can go either way. It depends upon how in depth you want to go. And of course, you could go do the fast track, see what you like, and then come back and do a full trial. So totally up to you. So we've tried to make it very easy for you, the operator, to go ahead and do this. You print this Grackle page. And by the way, I haven't really talked about this yet, but this Grackle page that you print, ideally, your digital presses often have multiple substrates that you run on it. Well, do you need a different profile for each substrate? Boy, I hope not, because that would mean a lot of profiling and it would mean a lot of different cues in your workflow to manage the different profiles. But chances are, especially if you're printing on coated and uncoated, you need at least two different profiles, because the visual difference between printing on a coated paper versus an uncoated paper is usually like 6 to 8 E factor, which, as we've talked about, is more than what most customers would accept. So you can take this target, print it on 10 different substrates, measure them all in, and then using a tool in ChromaChecker called a print condition qualifier, you can group these. And by the time I'm done talking to you, I could have shown it to you. So let me go in and actually show you this. So I'm going to go in and log in, and if you print the same target on 10 different substrates, or you might have 10 identical printers that all print on the same substrate, and you want to know, are these close enough? So you print them all on one printer, and I'm going to go in and I'm just going to make a new track. Just give me a sec, make a new track, which I'm going to use just for testing. And I'm going to go in and select some data off the fly of this target that was measured on multiple printing devices. And here it is. So same target printed on multiple printing devices. In fact, I'm going to choose some additional devices here and say open. ChromaChecker is bringing all that data in. So these are all pre-measurement data. So if you've already measured data for like G7 for G7 compliance, you can bring that data in ChromaChecker, and ChromaChecker will immediately tell you what the E factor is of that data to Grackle. And you can click on these two and see my CET versus my Muto. How different are they from one another? And you can see it's 9.6 E factor different from one another. And there's a little warning sign here telling me, hey, the paper difference is 9.6. So if you use ChromaChecker's paper capability, you can find a paper that potentially is a better match for printer A or printer B. And if you make the paper match better using ChromaChecker's database of paper, chances are the printers are going to visually match better as well, because paper is that 5th color and 4-color printing, and you want to make sure that it's right. So that's how easy it is to compare printers to one another. But now I'm going to select all the printers and go into this tool I called PC Qualifier. And I'll say, let's say I want all my printers to match within a 3E factor. I'm going to say confirm. And it says of the 16 printers, we need 10 groups. And these are the groups. So these 3 printers can print in the same group. These 5 printers can print in the same group. But every other printer has to have its own group because it's so different from the next. Now, if I increase my delta E or E factor threshold and say recalculate from 3 to 5, I'd go from 10 groups to 9. If I go to a 7, because I want to minimize the number of profiles, now I'm down to 5 profiles. So if I am allowing myself a 7 E factor, I have 5 groups. Now the CET and these 2 latexes can be grouped together. The CTET is the first in the group, so that's the one I profile. And the other 2 printers use that same profile. And then same here. This Fuji, that's the one I profile. These Mutos use that profile, and so forth. So in this way, ChromaChecker helps you group your papers, your printing devices, so that you can minimize the number of workflows that you need and the number of ICC profiles you need to maintain to keep your color quality where you need to keep it. So all these things are capable through this benchmark process. And then just kind of playing off the long-term implications of ChromaChecker, you can track how your printers are printing over time from both an accuracy and a variation standpoint. And just to show you, if I go back to my track and I say, hey, I want to see how my Komori press prints versus my Epson, which is an unfair comparison, versus my uh, color press. I'm now, instead of saying compare tracks, which I can do, which will tell me what the differences are between these 3 print processes, I'm going to say compare timeline, set equal intervals, and you can see this is my Epson at a 2E factor, and my color press from Xerox and my Komori press from Komori, they're both averaging about a 5E factor. Okay? That's over years of time. And by the way, this is all real life customer data. And you can see like the Epson kind of peaked up here around 3, and then they reprofiled it and brought it back down, which is part of the benefit of ChromaChecker. By ChromaChecking it, you know when you need to reprofile, or you know when you need a new G7 curve. I hear so many people going, well, when should I reprofile? And even experts in the industry will kind of hem and haw. Well, it depends upon. No, if you have the data, you can ChromaCheck it, and you'll know based on your expectations of your color match that you want when you need to reprofile it. These are basics that all of our current customers already understand. I apologize if we have a lot of current customers online here, but this is important for the industry to really recognize the uniqueness of ChromaChecker and why it's so useful. So we talked about comparing printers before you buy them to make sure they're right. So let's just finish in summary. It's hopefully you can see it's critical to know before you purchase if the printer is going to align with your current printing devices. By doing this benchmarking ahead of time, also you save a lot of R&D time on getting that printer up and running when it comes in, because you'll know what you're expecting. You're not trial and erroring it because some manager told you to buy this printer and make it work, which is part of the problem here and why I told you uh, if you're a ChromaChecker user here, please talk to your owners and have you ChromaCheck the printer before they buy it. Oh my goodness. If the owner sees this presentation, if they have any type of logical mind, they would never go out and buy a printer for whatever reason they buy a printer for. They would do their due diligence, scientifically sound, condition the PO on the demonstrated results, and then keep checking that printer over time to ensure you minimize your waste and keep all of your printers in a customer level sellable condition. And then use the ChromaChecker registry to find other companies to offload work from or to if your printers are too overloaded and you don't want to add another shift or you don't want to bring on another printer. It's genius. It's easy to do. So with that, do we have any questions?
Not currently.
I have a question.
Yeah.
Yes. Hi, David. Working at Ruggable, they're all the same printer. So this would really help just getting the E factor for the same printers, correct?
Right. Right. In fact, I didn't show that, but since you're bringing that up, I'm going to show it because it is so true. So I'm going to go back to my system profile and I went into this. Is this the one I did? Yeah, this is the one I did. So I brought data in here. I'm going to delete it all and I'm going to re-upload. And I have data all from a the same printer. So if I find it here, oh come on, I just had it. I have like 12 measurements, all from the same printing device. Back out one more level. Okay, here we go. Here I have 12 roll-in printers, all printing on the same material. I bring them all in. I can make one an OK sheet. So instead of referencing to Grackle, I can just reference to that sheet, and I'll just say Roland OK sheet, and I can make this global so all my other tracks can use it. And then what I'm going to do is I'm going to recalculate to that OK sheet. So now they're going to compare them all to that one print. And now I'm going to select them all and I'm going to do my PC qualifier to see if they all fit within a 3E factor, which is my default, and they all do. And here's a round robin calculation showing you rounding. Roland, one of the Rolands and another Roland is 3.12, but all the others are within a 3E factor of one another. And the Roland 10 is the most like all the other Rolands. Actually, there's 13 Rolands here because I think one's a 0. So that's the one I profile. And then I just share that profile between all the other Rolands. And then when I do mechanical head repair or replace a nozzle, what have you, I do it and I just check back against the baseline to make sure it's still in line with all my other Rolands and nothing else changes. So for you guys running all the same printing device, this is invaluable.
Yes.
Other questions? Well, I hope you found this informative, guys, and please feel free to hit us up with any questions online, and hope to see you at one of these events. Ideally, our color conference in February, and worst case, the Printing United show in Orlando next month. So have a great rest of your day, and thanks for your attendance.